Hi, everybody. This is Mr. Folly, and welcome to Podcast 12.1. We're going to be able to describe the characteristics of acids and bases. List common household products that are acids and bases, including vinegars, acetic acids, ammonia as a base. Explain acids are proton donors and bases are proton acceptors. Explain the definitions of acids and bases and use them to identify substances as acids and bases. So we've got definitions and properties. Define neutralization reactions. Zip, you're all gone. You're not what you used to be. Differentiate between strong and weak. Wow, that's a lot of stuff. I have strong and weak bases. So let's hop into it. We've got our blue bases. Let's see what our red acids look like. When I cut that off a little too soon, didn't I? All right, so taste. Acids taste sour. Oh, I should do this. I should do the base part in blue and the red part in here. Bases taste bitter. Now, I have to admit, I don't know the difference between bitter and sour, or bitter, as I put there. So, and neutral tastes like nothing, right? So neutral things don't have taste, so it tastes like chicken. Chicken supposedly tastes like nothing. So I hope you put nothing instead of chicken, but I think you already put chicken. It feels slippery. Litmus, a base turns blue. In phenolphthalein, a base turns pink. Conductivity is yes or high. pH is above 7. If you add a metal, nothing. Nothing. Add carbonate, nothing. And for a neutral thing, it feels guilty, which means nothing special. Litmus has no change. So if it's red, it stays red. If it's blue, it stays blue. If it's phenolphthalein, it will be clear or colorless in most of them. Conductivity will be mostly low for neutrals, but that's kind of on its own. pH is 7.0, and nothing. So let me turn to rayod. Rayod. There's rayod, I hope. Taste, sour. Feels sticky. Litmus turns rayod. So this is how you can remember. Acid turns rayod. Kind of rhymes there, don't it? Acid turns rayod. And this is colorless here. Conductivity, yes, and high. High. pH below 7. Add a metal, it reacts, which means bubbles. It dissolves it. Add a carbonate, which you can't just add an ion to it, but it'll bubble. Let's keep going. So what is vinegar? Okay, so vinegar. If you touch vinegar, is it sticky? Not really. When you taste it, does it taste sour? Okay, it tastes sour. pH is about 4-ish, so it's an acid. Ammonia. It's a cleaner. It's slippery. And its pH is about 9, so it is a base. Cleaning supplies are bases. OJ is a sticky acid. Gastric juices, oh, well, kind of get that taste in your mouth. Isn't that terrible? So gastric juices would be sour, acid. Banana peel, slippery. Look out! That's funny right there. He fell on a banana peel. So it's a base. Indicators help tell you the pH. So you don't need to know these specific indicators at all, but you just need to know the different indicators are different colors. And if you read this, by the way, if I'm looking at alizarin yellow and I'm looking at a pH of 4, it's going to be yellow. So this yellow lasts all the way through here. You probably think, Mr. Foley, that's red. Yeah, you're funny. But it's true, I can't tell the difference. And this blue would go all the way here, would be blue. But I don't know why I didn't show that the whole way there, but you get the idea. So a different one. Find the pH if phenol red is yellow. Phenol red is yellow, which means that it's below 7. And bromthiamyl blue is yellow. Bromthiamyl blue is yellow, which means it's below 6.5. See how I got the 6.5? 7. And chlorophenol red is rayod. So if chlorophenol red is red, that means it's got to be above 5.8. So that means its pH is between 5.8 to 6.5. That's it. That's how you just got to be able to do these things. Chemistry of acid bases. Acid. Hello, I'm an acid. Acids take H's. They usually start with H's. Often, but not always, start with H's. That's the Arrhenius definition. Not always, but often, start with H's. So I have HCl. Notice HCl gives an H to water. It's an H giver. And water, this by the way is an acid. This is a base. Okay, an acid is an H giver. A base is an H taker. Okay, so this base takes an H as it goes through here, and I'm left with this guy. NaOH, HCl. Notice H again is going to give it to OH, right? Water. And then these guys just kind of pair up in the end, NaCl. Okay, so again, this is the acid base. H positive and H3O positive are the same thing, and by the same I mean exactly the same thing. They are the same thing as if I said I had an A and I had a 95%. Both of them are A's. Both of them are the same thing. H positive loves the negative around water and bonds like an annoying couple in the hallway. How can they always be together? So if I have H2O and I have H positive, it's like, oh, they're all over each other like that horribly annoying couple in the hallway. They are never, ever, ever not like disgusting. Neutralization. Smile, little guy, it'll get better. No, it won't. It'll never be the same. Neuter, to take away your identity. If an acid is neutralized, it no longer is an acid, meaning it's no longer sticky, it no longer has pH of whatever it is, blah, blah, blah. If a base is neutralized, it's no longer base, it's no longer slippery, it never has pH of whatever it is. HF plus NaOH will make HOH, water, plus NaF. Is a product an acid or a base? Yes, this is water. This is not. It's neither. A neutralization reaction always makes, hey, I'm glad you're writing this down, makes a salt, which is an ionic compound, and water. That's H2O. Examples. HNO3 plus KOH. Acid. Hello, I'm an acid. And a base. Oh, I had an OH. I'm a base. So I'm going to get H2O, water, and salt. KNO3. K is plus 1, nitrates minus 1. Hey, I memorized those. I'm so happy. HNO2. Hello, I'm an acid. Oh, I'm a base. These guys are going to make new friends, H2O. And then I'm going to have FeNO2. But Fe, see this guy right here? Plus 2. Nitrite, I memorized that one. It's going to become, takes two negative 1s, right? This is negative 1, this is plus 2. It takes 2 nitrites to balance the irons. Acid plus base equals salt and water. Strong acids and strong bases. Strong acids and bases ionize 100%. 100%. The strong acids are these 6 guys right here. Hello, I'm an acid, a strong acid. Strong acid, strong acid, strong acid, strong acid, strong acid. Strong bases are group 1 and 2 hydroxides. So on the periodic table, oops, boop, boop. If you're a hydroxide in this region right here, you are strong. Switch HNO2. Is it strong? That's NO3, not NO2. Weak! Acid. Calcium hydroxide. Calcium hydroxide. Strong. Base. Hello, I'm an acid. Hello, I'm a strong acid. NH3 we need to memorize as a base. It is ammonia, not ammonium. We need to memorize as a base, and it's a weak base. It's the base we use most often for a weak base. Ding. Concentration does not equal strength. Concentration does not equal strength. Concentration does not equal strength. Strength is how much you separate. Concentration is how packed in you are. Okay? So we basically say bigger than 1 molar equals concentrated. Less than 1 molar equals dilute. Strong is basically, are you one of our strong guys? Okay. Less than 1. It is a dilute, because less than 1. Hello, I'm an acid. HCl is one of my strong acids. Strong acid. Hello, I'm an acid. Oh, I'm a strong acid. What? How do you know that? 10 molar, that's bigger than 1. I'm a concentrated, strong acid. Less than 1. Dilute. HNO2. Hey, that's not that one, so it must be a weak acid. 315. Hey, that's a big molarity, so that means it's a concentrated. Hello, I'm an acid, but is it strong? HF is weak. Hey, that's a base, it ends in OH. Hey, that's a concentrated. Concentrated. Is it strong? See, that is sodium is in group 1 of the periodic table. What's in here? So it's strong. Concentrated, strong base. Boom, 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 boom. Hello, I'm an acid. Friendly and an H giver. Hello, I'm an acid. Acids and bases always make salt and water. If it is rayid, acid, concentration does not equal strength. Indicators change color different pHs. And don't be colorblind in chemistry. And after that, all I have left to say is toodles.